When we talk about jigs and fixtures, we use things. I know about this when I was learning to become a little woodworker in 7th, 8th grade. I had a job, and I was in 7th grade, so you could only do so good, like drilling holes, right? So the guy that I was working at made this jig, so I put this block in, drill this hole exactly in the same spot every time, okay? And it's a device that holds or locates a piece of work that guides tools to operate upon it. Okay, right here's one for the table saw. We'll have jigs for the mill that you're going to be learning how to use, so that when you put that piece of aluminum, that block of aluminum in here, to go get milled, it's going to go right up against that edge. The back walls against the edge. We don't have to worry about where it is, and the machine knows where it is, and it can start milling. A fixture is designed and built for holding. So how you hold something. And so fixture is more of what we're probably going to be using in the mill. A jig locates the piece of work that holds that piece of work. So sometimes your fingers don't have to be right next to that blade. Sometimes that's all it does. Sometimes it holds it in place, okay? And basically the rest of this presentation is showing pictures of different jigs and fixtures that you may have seen before. This one is for making, I know, it's for making dovetailed drawers. Like pull-out drawers where they dovetail, where you set them in, you glue them, and they sit in the side at 90 degrees, for the drawers themselves. You could do this. Used to have to do it by hand in a little hand saw, but you don't get near the quality. Safety, so you're not having your fingers right next to the device. Hopefully, repeatability. Okay. Jig adjustable fence found in most table saws right here. You see them all over the place. A hold down clamp on a compound miter saw so that you don't have to put your fingers on it. Okay. Here's just a vise for a drill press. Okay. Here is a simple vise system in the bed of a milling machine. They got these types of clamps. We're going to learn a little bit about this. I just want you to know that there's almost always a way to hold something. But they have to be almost as creative. In fact, most of your two guys that work on the machines, the main part of their creativity comes from how to hold that part down and not wreck it and not have it move. And not have your mill bit go into that or that and ruin it. Okay, we're not gonna. V blocks are for holding rounding. The strap clamps you may see, may not. I don't want you to know, people, that every jig and fixture. Okay, I just want you to know that there are many different jigs out there and fixtures out there to hold things. This is an air vise where it'll hold it in. Yeah. All right. Now the next one is about different machines. Okay, when we watch that video, I am gonna. With Jess on it, they talked about starting their own business. And I think some of this is similar to what we do here, is creating a new product, right? And you're saying it's not, you think it's a linear process. It's not. You're constantly going back. Same thing with the problem solving process. Same thing with the entrepreneur process or the design process. So they built that prototype, and then they had to check it with different people to see if it was any good, right? Their next step is taking it to beekeepers and see if they think it's any good. And if it is, they got a sellable product, right? If it isn't, well, maybe not. Okay. Now, machines. Whenever time you work on machines, safety guidelines must be followed. Safety glasses, and read instruction manuals, observe all safety rules. When we're using the mill, when we're in there, need to have closed-toed shoes. Okay. Safety glasses need to be on. All right. Using automation. Why? Or different elements of that. CNC, computer-numerated control, robotics, transfer systems, and then inspection and feedback. Now, at many places, I'm going to start from the bottom here, inspection and feedback. They have cameras. What they have found, like, okay, so let's say we're going to make these widgets, right? And we got to see if there's any problems with it. And they would used to they'd have an employee look at it, Well, as you can imagine, asking someone to do that for 8 hours a day for the next 10 days, how boring that would be, right? And the more boring a job gets, the more likely that person's going to take a look at that. And there's a little flaw there and maybe not even notice it, right? Because you're working, 8 hours, you're tired, whatever, and you're just like, yep, and you're letting it go by. So what they've done a lot of times is taken an infrared camera, taken points on that, go up, boom, they take a picture of it, and there's certain spots that they need to see in that type of camera, and then it goes on to the next step. They just inspected it, okay? Found it to be much more accurate than having a person looking at it and moving it down. And nobody really wants that job unless they don't have a job, right? I mean, I don't think anybody here would be like, yes, I want to inspect something for 8 hours at a time. Transfer system, automated guided vehicles. We made them in POE, if you remember that, go back and forth. So different moving parts. So you don't have to have someone go over there, carry something heavy, bring it back. Robots and CNC machines. Here are an example of CNC machines. Mills, lathes, machining centers, which is more a plasma table. We have a mill, we have a lathe, we have a plasma table. We do not have water jet or wire EDM. We have a laser cutter and engraver, and we do have rapid prototyping with our 3D printers. Okay? Mills and lathes, machining centers, they cut. Water jet, they cut. Subtractive manufacturing. Okay? Wire EDM, subtractive. They go in, you would mill out something and it would heat up, and it's basically they make these graphite electrodes, and it would go in there and you would put it in and it would basically eat out the inside of that with an electrode. Used for really, really close, fine work a lot of times. This is going to be, my opinion, replaced with 5-axis, 6-axis hybrid machines, where they can weld, 3D printer / mills, where they can weld, then mill it, and be able to move that item up. Okay? My opinion, could be wrong, or at least it will take some of the place. Yes?
So do they use the wire EDMs to hollow out metal?
Or they can use them also to cut. Yep. Okay. Yeah, like you see a lot of it at SMC and making molds. They'll take, they'll make something out of graphite, and then that'll go into the wire EDM machine and cut it out. Cut it out. Again, I'm not going to get too much into this, but CNC machines right here perform same function as conventional machines in joint separating casting. Highly productive and cost effective because after you make one, you can now put it in there and make another. Okay. Here are some CNC mill bits. We're going to be seeing those a lot. I'll grab some down. This is a center cutting end mill, 2 flute. 1, 2. Okay, that's, as you can see, it's going to be a curved ball end. Here's a 4 flute center mill, and this is, and I just got one of those. So wide, and it goes in there, and it's for taking a piece of aluminum, you put it on there, and it flattens it out. And you only have, if you had to do it something like this, you'd have to make lots of passes. With this thing, you just go by maybe once or twice, and it flattens out that. All right, robots, welding and joining, right? Anything that you've seen in the metals lab, a robot can do a lot of that. They can also plasma cut. When they talk about resistance weld, there's spot weld. If we ever seen that, they can spot weld sheet metal. See that in cars. Material handling, you see this a lot, and we're going to be going to take a trip into SMC, and we'll see how robots are used for assembly, picking, moving stuff, where now people don't have to sit there and pack 1,000 of these to put them on a pallet, right? Where before they had to. AGVs are automatic guided vehicles. I'm not sure what ASRS are. Oh, yes, they're automated storage retrieval systems. So I need a part. I can have it come bring it in. Go grab it for me. And I don't have to get up, walk over, find where that part is, bring it back and work. This will bring me the parts that I need. Conveyor system and then a parts feeder. We talked about that. All right. So let's go over and take a look at our mill after I end this stream. Oh, anybody, how many here are interested in robotics this year?